Hello, everyone. So this is the part where the gas laws get tricky, and that is with the partial pressures. So Dalton's law, Dalton's law of partial pressure states that gases in a mixture act independently. Or basically, their totals come together. They're each their own. All the elements or compounds in the mixture can have their own pressures and can do their own thing. So, because of this wonderful law, we get to go back to moles, which I know we all loved forgetting. But we're back to moles. So we have this new thing called a mole fraction. So what a mole fraction is in this instance, it's represented by x of some element, say element A, and the mole fraction equals moles of that substance A over the total moles of the mixture, which doesn't seem too bad until you start getting into the equation. But something to note about the mole fractions, all mole fractions in problem equation will add up to 1. They'll all add up to a whole. So all your fractions will add up to 1, which means they are going to be less than 1. That's a key way to know if you're doing it right. And an equation we get with this partial pressure is that the partial pressure of a gas equals the mole fraction of that gas times the total pressure of that mixture. So PA equals the partial pressure. X of A is that mole fraction, and then PT is the total pressure. So probably XA is the mole fraction. So probably the best way to start out is to start with this mole fraction. Let's start simple and build our way up. So say we have a mixture, and it has 2 moles of hydrogen, has 3 moles of ammonia, 4 moles of CO2, and 5 moles of nitrogen. So we want to find, and the total pressure of this mixture is 800 torr. So we want to find the partial pressures of each element. I'm not going to do all 4 because that's a lot of work, but I'll start. So say we want to find the partial pressure of hydrogen. The partial pressure equals the mole fraction. So we know so first we have to start with the mole fractions. The mole fraction is the moles of the element we're looking for over the total. Now we can add these all up, 2, 3, 4, 5, that will make 14. So that's the total moles. But you actually don't need units here, because this makes just a ratio. So you don't need units on your mole fraction, it's just a number. You do need units on this next part. So mole fraction times the total pressure. See, now we have our unit is going to be a pressure. So stick this in the calculator. It's 114 torr. Now, if you were to do the mole fractions for all of the elements, so say if we did ammonia, it would be 3 moles over 14. If we did CO2, that would be 4 moles over 14. And then nitrogen would be 5 moles over 14. Now, we do all those, we times it by 800. But you can see all of these mole ratios, fractions, I don't remember anymore, would add up to 1. You'd get 1, as I was saying at the beginning. So that's how to set up these mole ratios, kind of the gist of these equations. Let's do one a little bit more involved. So say we have the partial pressure of argon is 302 milligrams mercury. And then the partial pressure of nitrogen is 549 milligrams of mercury. And we have the total pressure is 851 milligrams. So we're looking for the mole fractions, the mole ratios. I really don't remember what they're called at this point. So we know the formula is partial pressure equals mole ratio times total. So just like we were doing with the gas laws, we're trying to find x, we just need to divide by p and get x equals PR over P total. And then we can just plug in, we have from the equation, from the problem, what they gave us. And then if we plug that in the calculator, we get that the mole ratio of argon is 355. So they're asking for the mole ratio. That's what you're going to get. That's probably not what they're going to ask for. Let's do another one. That was simple. This is where it starts to get confusing. So say our total pressure is 942 milligrams of mercury. Our partial pressure of argon is 552 milligrams of mercury. And we know we have 3.9 grams argon in this mixture. Okay, we want to find how many grams of nitrogen is in this equation. Well, one thing we can find is the partial pressure of nitrogen. That would just be the total minus argon's partial. So that gives you the partial pressure of nitrogen is 690 mercuries. Okay, so to figure out how many grams of nitrogen, the first thing we're going to need to do is get some mole ratios to figure this out. First, we need moles. So we need to convert these grams of argon into moles. So if you remember how to do this, you take your given, and then you take the atomic weight off the periodic table. You put it on the bottom so the units cancel over 1 mole. So that gives us 0.096 moles of argon. So now that we have moles of argon, we're going to hold off on moles of argon for a minute. Now we're going to get the mole ratio of nitrogen. So X of N, as we saw earlier, equals P of N over P total. So that would be, we know the partial pressure of nitrogen, there should be 2's, is 960. We know our total pressure is 945. So we plug that in the calculator. Our mole ratio for nitrogen, 732. Okay, that's great. That's just the ratio of the moles. We need total moles, and we're trying to get to grams of nitrogen. Right now we have the mole ratio of nitrogen. But we know the mole ratio of nitrogen gas equals moles of nitrogen over the total moles. Well, we don't have the total mole. We only have, as of right now, we know the ratio, but we don't know the total or the moles. We're trying to find moles of nitrogen, but we do know how many moles of argon we have. So we can say the mole ratio of argon equals argon's partial over the total. And that's supposed to be a 2, not a 5. Great. Okay. And that equals 0.268. Okay. So now that we have the mole ratio of argon, we can figure out how many total moles we have, because total moles equals moles of argon over the mole ratio of argon. And we just do that because we took this equation, cross multiply, divide back again. So total moles, Tm, equals R, we had 0.0976 moles of argon earlier, and our mole ratio, 0.268. Put that in the calculator, that gives you 0.364. So this is how many moles total are in this mixture. Now that we have this, we can go back, and moles of nitrogen gas equals its mole ratio times total moles. So that equals 0.732 times 0.6364. And that gives us 0.266 moles nitrogen. That's great. Now we have to go back to grams to figure out how many grams. So we set up a conversion. We want moles on the bottom this time to cancel out. Put grams, make sure you double it because nitrogen is a Brinkelhoff. So we need to get double it. These cancel. And we get 7.45 grams of nitrogen. So one more thing with partial pressures is our favorite man, Avogadro. If you remember his lovely number, Avogadro had a hypothesis. I can spell hypothesis. Okay, Avogadro's hypothesis was equal volumes of gases at the same temperature and pressure have the same number of molecules. So what this boils down to is that volume over moles is equal to volume over moles, and they're directly related. Volume and moles are directly related. That was his hypothesis. And N is number of moles. So this is just like all those other gas laws. You need me to do an example using this, I can, but I think it's pretty self-explanatory. So that is partial pressures. If you have any questions or need me to do more examples, it's a little too late for the quiz, but before the test, I can definitely do some more. So I hope this helps. Thank you so much.